There are situations when working with relational expressions where just one relational expression won't do. Say, for example, you're writing a payroll program, and the only people that can get overtime are people who work over 40 hours a week and make less than, say, $50,000 a year. So your two relational expressions would have to be hours worked greater than 40 and salary less than or equal to $50,000. So you see that and combines the first relational expression with the second relational expression. There's also an or connective where you might say, like, if username equals name or username equals username, something like that. We'll look at some examples here in just a second. The first logical operator is the and. And is written with two ampersands, like so. Let's take a look at an example. I'll do a little program here. We won't actually calculate anything, but I'll use that to demonstrate how the and works. So here I have an integer variable hours worked that's equal to 43 and a salary variable that's equal to 47,000. Let me indent those, get them off the comments there. If I wanted to compare these two in the payroll example I used earlier, I might write it out like this, although I wouldn't put it in a system out print line. So I'll write hours worked greater than 40 and salary less than or equal to 50,000. So the and combines this expression's result, its Boolean result, with this expression's result. So if you remember anything about logic or discrete math, you know that the truth table for and, for both expressions to be true, each sub-expression has to be true. So in this case, this whole expression, hours worked greater than 40 and salary less than or equal to 50,000, is true because both sub-expressions are true. If we changed hours worked to 39, for example, then the whole expression would be false because the first part of the expression is false. So that's how the logical and works. The other operator that we're going to talk about now, there's actually a third not, which we're going to save for another time. The other operator, or, looks like this. It's two bars, and the bar is a shift backslash on your keyboard. So the two bars is the or logical operator. And let's take a look at how that would work. Let's say we have string password equals, and what we might do in a password situation is we might check it both when it's all lowercase or all uppercase. So we might write something like this. Password equals lowercase guest, or password equals like so. And again, from discrete math or logic, we know that if either sub-expression is true, then the whole expression is true. So in this case, the expression is true because this part or this sub-expression is true. Password equals lowercase guest. Both sub-expressions don't have to be true, just one or the other, and it doesn't matter which one. So if the password had been stored like this, then the second sub-expression would be true, and the whole expression, the whole or expression, would be true because the second part was true. Logical operators are used in more complex situations, and quite honestly, they don't come up all that often in an introductory Java course, but they do come up enough that we needed to talk about how they work. With this discussion of the relational operators and the discussion of the logical operators, we're ready to move on and begin looking at how to actually make decisions in Java by discussing the if statement, and we'll do that in the next video.